Hi guys, welcome back to 100 Days Machine Learning Crash Course. Today we want to see a more advanced example in Keras and how to use Keras for different layers for convolution transpose or the convolution layer for regularization and some other things that maybe it is better to see in a more advanced example. So let's say our task is to maybe do some sort of maybe image denoising or segmentation or something like that. So in this case, let's say we want to build this network. So this is image, then we want to our CNN we want to have Day68 as a feature extractor. So this is the part of the CNN of our CNN that is pre-trained on ImageNet, and we want to freeze that and just use it as a feature extractor part. And then we want to add some deconv layers or convolution transpose layers to again build, let's say if the task is denoising, then again we want to build an RGB or BGR image. Depends on if you use OpenCV, then it is probably BGR image. Okay, so it depends on how you read your data and how to feed them in the network. Okay, so we want to build some model like this. Let's start. So let's call it or enhancement or denoising. So I want to just introduce to you some different layers and actually how to use Keras in a more advanced way. So the first thing that we want is the backbone Day68 from Keras. So as we saw in previous sessions, the Keras actually has VGG, ResNet, and other backbones. So we could import that from Keras that applications. We import the model. Okay, and also just note that when you want to pass your image into a pre-trained network, because that pre-trained network trained with some specific pre-processing for the input, so you should do the same pre-processing on your new inputs. Okay, so now we need to use the same pre-processing as the Day68 did in its training process on our new data. So the Keras also has its pre-processing. So from Day68 we import pre-process input. Okay, now let's define get model function and build the model in this function. Okay, so the first thing that we should do is let's just define this Day68. So we want the weights to be ImageNet. Don't worry if you don't know the arguments. You could go to the Keras documents to read about these arguments. Okay, so the first argument is the weights, because we want to use the pre-trained Day68 that is trained on ImageNet. So we use ImageNet, and also we don't want to include, let's just run this to have auto completion. and we don't want to include top. If you remembered, in VGG16 we had some dense layers. Oops. We had some, so after convolutional layers we had some dense layers. We call this top of the model. So in here, because we just want to extract some features, we don't want this top of the model, so we just don't include the top or the dense layers. And the input shape, let's say we have the standard size of 224, and this is the number of channels. Okay, now we should create the input layer. Okay, the input layer, for input layer we should, from Keras.layers, we should import input layer or input. Okay, so let's call the input X is the input, the shape is, let's say 224, because we want to pass the input to the VGG, and the input shape of VGG should be the same as the input of the total network. So if you now get that, we are building this block. So now by using this line, we now built this. Now we should build the input image or the input layer, which is this one, and pass it through this VGG, and then add some decon layer after that. Okay, so this is the input shape. You don't need to include the batch size in here. So in the training process, when you want to train, the batch size will be included or will be attached in the first access. So for example, if you use 8, the batch size 8, then the input of the network will be something like this. Okay, so the first number is the batch size. By default, the Keras put question mark instead of that. Okay, so we want to, let's call it feature extraction. So we want to have feature extraction part. Maybe it's better to just not to be confused. Let's do this in here. And also, because the default input size is 224, we don't need to pass that, and we could just remove this thing. Okay, so we have this model, and which is a feature extractor, and we want to freeze that model. Okay, so we have something for freezing the model. In other words, we don't want to update the weights for VGG when we are doing backpropagation. So we have something called trainable. For the models, we could set that equal to false to not train or retrain the VGG. Okay. Now we should use this network, because this is a network, this is not a layer. Okay, so we use this network and pass the input layer to this model to get the output. Okay, so this is the extracted feature from the input, or feature of X. Okay, so now we could use the same name because it is not important. Now we want to, so actually until now we built the model until this point, so we now should stack the convolutional layers, or convolution transpose layers. Okay, so from layers we should import convolution transpose in here. as you could see. So we use convolution 2D transpose. Let's say we use 256 filters with the size 3 by 3, and we use the strides 4 by 4 in order to have a scale number of 4 in the upsampling of the input. We will see how this model, the architecture of the model in some next lines. We introduce a model summary method in which we could see how different layers interact with each other. Okay, and to use the regularization, we know that we talked about it in Keras. You should use the regularization in the layers. So let's say we want to use an L2 regularization for this convolutional transpose layer. So we should import from Keras, we should import regularizers. Okay, now simply in here we could write kernel regularizer, as you could see, is equal to regularizer dot L2, because we want to use L2 0.01, let's say. So this is the lambda that we talked about it, and the input layer for this, if you remember that we should pass the input layer to the current layer, which is the previous layer name. Okay, after that, let's say we want to add leaky relu as the activation function. So if you remember, if you have a simple activation function like relu or tangent, hyperbolic or sigmoid, you could write this in here. But if you want to use more advanced activation functions like relu, you should use activation layer, and also from Keras.activations you should import from Keras.advanced activation functions, we should import leaky relu. Okay, now in here we could have another layer with the name of activation, and we want to have leaky relu as the activation function. And as you know, the leaky relu has a parameter that specify, so we know that this is the relu in the positive region is something like this, and in the negative region it has a small slope. So and the slope of this line is alpha, so we could specify the alpha in here. Typically you should use cross-validation to if you want to really have a tuned model, but maybe 0.1 is a great starting point for alpha. And after that you should pass the previous layer to this layer, which is X. Okay, now let's add another convolution transpose and activation functions, but so we want to have this kind of architecture. So first we have lots of channels after this feature extraction. Now we are decreasing the number of channels and we are enlarging the spatial size. So from the channels we are enlarging the spatial resolution but decreasing the number of channels. So in the next step we want to have 128 channels, and after that we want, or at least let's say we just want to have 3 deconvolutional layers, and at the last layer, because we want to have 3 channels, we should have 3 in here, because the number of filters, if you remember that, the number of filters specify the output number of channels. And for the output layer, because I want to get the same input size, I should use 2 by 2. Actually, if you wonder how I know that, I look at the output of this thing. I will show you in a short how to use this scaling to know that what is the output of this. Okay, so 2 by 2, and also the padding should be the same to have no extra increase in the spatial size. And if you normalize your output images to be in the range of -1 to 1, you could use tangent hyperbolic as the activation function. So it is important. So because if you use, let's say, ReLU or other activation functions, and let's say you just mapped your outputs in the range 0 to 1, then maybe for some inputs, when you are testing your model, you see some pixels that are overexposed. Okay, in that case, maybe the output of the model is, let's say, 1.2, because you put the ReLU, so the ReLU could get you whatever, so it does not bound the output. Okay, so maybe it gives you 1.2, and then you probably scale it by 255 to show it by OpenCV, and then you will see some overexposed pixels. But if you don't want to see those, you could use tangent hyperbolic to if you want to adjust the range of your output data in the range of -1 to 1, or if you want to adjust the range in the 0 to 1, you could use sigmoid activation function. Okay, so let's say it is tangent hyperbolic. So now we could create the model. Okay, so the model is, the inputs of the model is x, just x. The input has only one input, and the outputs is feature x in here. Okay, a cool feature in the Keras is that you could use model summary, which we know about it, but also you could save the model, the plot of the architecture of the model with plot model. Let's see how to use that. So to save the architecture of your model as an image, you should import plot model from the Keras. So from keras.utils we import plot model, and in here we could use plot model, and the inputs are just simply the model, and we have a to file which is your output. Let's say it is image model or denoising model.png, and you could use the show of shapes equal to true, and show layer names maybe true. Also you could specify, it is optional for your layers to have some name. Okay, so that they could have different names, and then you could show them, but by default they are just sequentially will be named by the Keras itself. Okay, and after that we want to return the model. Okay, I think now we could use the model, so it is get model. Oops, we have some error. Oh, okay, I just figured that out. You should, instead of using Keras application, you should use Keras.applications. And okay, let's run this guy. Okay, that's fine. Okay, now let's see the saved model. We have the model in here. Okay, great, that is great. You could save your model as an image. And also, let's see the summary. So the input shape of the model is 224 by 3. Okay, so and this is the batch size, so this is none, because your model don't know which batch size you want to get to the model, or it could be anything. Okay, so it is none. And but other dimensions are specified. Okay, after that we use the VGG16, and you could see that we have lots of parameters for the VGG. And after that we have a convolution transpose layer. So the output, you could see the output shape of the layer, and by this I just play with strides and the padding to get the same output. Okay, so instead of convolution transpose, you could also use upsampling layer. So the upsampling layer basically just scale your in fact your feature maps into a larger or smaller scale. Okay, so in here we use convolution transpose layers. We have strides. Okay, and the output is, as you could see, is the same as input. So you could prepare your data to be 224 by 224, and also for the output, so you have some inputs with noise and we have some output without noise, and just train the model to learn how to denoise the image. Okay, and let's see, the total parameters of the model is 16 million parameters, but because the most parameters are in VGG and we freeze the VGG, the non-trainable parameters is 14 million, okay, which is quite high. And for trainable parameters we just have 1 million, or roughly 1.5 million parameters to train the model. Okay, so that is so cool that we use the pre-trained model of VGG to use that in our task. Okay, and so this is how could you create, how you could create the model. And another thing that maybe is good to know is that, because now you know how to use how to train the model. We saw that in previous example, so in last session. So you should just note that when you use pre-trained model and a deep network, you should set a really small learning rate. So if in MNIST example, if you remember that, I think I used 0.01 as the initial learning rate. Okay, or if you use Adam, the default learning rate for that is 1a-3, okay, which is 0.001. But if you want to use the pre-trained models in your whole model, you should know that you should decrease this learning rate and set that to something like 1 in minus 5 or 1 in minus 0, 1 in minus 6 to train your model. Otherwise, the learning rate will be so large for the whole model, and you don't have probably, or you will have something like this for the loss function, and you will see that the loss function does not decrease when you train your model. So in that case, try to decrease the learning rate to get some curve like this. Okay, and now you know how to use TensorBoard to track your loss functions and all of this stuff. Okay, now actually there are lots of other things that you could use. For example, if you are using classification, then and you want, in that case, you could use some cool features of Keras, that is the data augmentation by Keras. So the Keras has something, it's called image data generator, that could automatically augment your data in the training process for you. Okay, so in here, in this, if it is not classification task, you should actually, if you want to do augmentation, you could first augment your data, for example, rotate some data, scale some data, and so on, and then store them. Okay, but if you use the image data generator class of Keras, it automatically creates for augmented data for you in the training time, and it is so cool. You could just specify some things and some adjustment that you want. For example, you want to width shift range and adjust that, and the height shift range, and so on, and just Keras will create and augment new data from your training data to your model and fit those to your model randomly. And so you could use this image data generator of Keras. Also, actually Keras has lots of other things that you could use. For example, in Keras you could use custom loss function. If you want to create custom loss function, you could search. There are lots of different things in both Keras itself and other things, and also you could see the existed loss functions and metrics that you could use for now. And so actually there are lots of things in Keras, and we could not cover all of those. We are just trying to make you ready to be able to search and build some models, go to GitHub, try to clone them, and just play with them, train them, try to ask your questions, and I will answer them as soon as possible. And yeah, because this is a very vast majority, and the vast majority of tasks, and it depends on what things that you want to work in. For example, if you want to work in the natural processing, natural language processing area, you probably need different tools in Keras. If you want to use Keras, if you are working in computer vision area, you will need different things. So we could not cover all of those, but we try to provide necessary tools and necessary things in Keras, and you would be able to discover other things based on your needs yourself. Okay, I hope that you enjoyed from this session, and hope to see you in the next session. Bye.